Hey guys, continuing with anti-differentiation techniques for our very simplest kind of functions, our polynomials here is more simplest. Well, the way it's written is actually not a polynomial. I'm going to work with this first top one right here. This doesn't look like a polynomial right now. It's like a rational function. But of course, since I just have an x to the fourth in the bottom, I can rewrite this in a simpler form where I could go ahead and use that reverse power rule along with some properties of integration that we learned earlier. So let's see, if I go ahead and divide x fourth into each term here, I would have a negative x to the negative 2 in this first one. I'm integrating this whole thing. Negative x to the negative 2 plus x to the negative 3. And that's looking like, oh man, I can about go of course, my dx. I can about go use my rule now. Of course, we can go ahead and we learned that when we have a sum, we can integrate each part. So we have a negative x to the negative 2 dx plus the integral, the antiderivative, indefinite integral of x to the negative 3 dx. Okay. So now it's just a matter of using that old reverse power rule. If I add 1 to that, I get x to the negative 1. I multiply by the reciprocal. That just gives me a negative 1 times the negative. That's good to go. Of course, I could put I'm going to put a plus c1 there, remind me, for that part. And then for the next part, let's see, going up 1 will give me x to the negative 2. And I have a negative 1/2 out front, right? Because I've got to take that over top, and then I'm going to say plus c2. Well, this function generally works, but c1 and c2, I don't know what they are anyway, so I can just call them c. So in general, we'll say the antiderivative here is x to the negative 1 minus 1/2 x to the negative 2 plus c. Okay. And so that's that is the family of functions that is the antiderivative. And of course, on this one, I'll just let you finish it out, but you're going to rewrite this one. You guys know how to rewrite this using rational exponents. This is the integral of x to the 2/5 dx. And now it's not so tough to do. I'll talk with you soon. Bye-bye.